All right, let's talk about decision tables. So up to this point, the types of input that we've considered are on themselves fairly simple to represent, either arithmetically or as a function, and logically. But when you start considering multiple rules, fairly complex rules that have to be taken into consideration together in fairly complex ways that together combine using predicates or Boolean expressions, right? Oftentimes it's easier to represent those rules as decision tables, right? Where you can quickly list all those rules in a separate row, and then consider the values, whether they're binary or whether they're numerical. Consider all their possible values and combinations of them, right? Obviously, it's easier if they are a Boolean, right? And then you can just list out all the possible combinations of Boolean truth table, and then decide what the results would be with all the different combinations, right? So the decision tables can be very useful, especially they're very compact. They're very easy to visualize very quickly what all the different combinations are, and quickly look at and spot the mistakes. And oftentimes they're very easy to translate into executable code. You're looking at all these combinations. So for instance, here's an example of multiple rules that on their own they're pretty simple to implement, right? But when you're taking into account all the possible combinations, right, of wanting to calculate something based on all these different rules, then it could be fairly complex. So for instance, the first one says, if the charter is longer than 4 hours, then you get a 10% discount, right? If you are fewer than 3, right, then there's no need for a captain to go with you. You get a 5% discount. If this is off season, and if it's between September and April, then you get a 10% discount. But if you're between May and August, then you don't get the discount, right? So again, all these work together to come up with a final discount, right? Because the last rule says that all these discounts can be cumulative and they can all be taken. All multiple discounts can apply, right? So you could be off season and less than 3 and for more than 4 hours, right? So you would cumulatively say 10 plus 5 plus 10, you get a total of 25% discount, right? So your algorithm would need to take into account all these different rules to come up with a final discount. Now, the easiest way to represent this is through a table where you can, at each row, list all these rules. And now, obviously, these are fairly simple that they are binary, right? It's either you're on an off season or not. You're less than 4 hours or not, right? You have less than 3 folks or not, right? And you can easily just list all the possible combinations. There's 3 options. There's 3 variables, each one with 2 options. It comes out to be 8 possible combinations. And down below, you can list all the resulting calculations of what the total discounts might be. Now, implementing this would be trivial. Be very easy for us to convert this table into something that is implementable.